Greenville does have an environmental advisory committee, and this committee has a subcommittee of folks who were trying to help out with planning for changes for the climate adaptation. And we had about 20 volunteers on this committee, and these are the folks who did the calculations. So this is an example of calculations done entirely by volunteers without any help from the professionals or people who had lots of time to put into it. When we started looking at this, we ran into an organization that we've quite commonly heard of, the International Council for Local Environmental Initiatives, which everybody calls I.C.L.E.I. And this is a nonprofit organization that does go out and help municipal governments do their greenhouse gas calculations and develop action plans to reduce their emissions. I.C.L.E.I has helped over 300 municipalities in the United States and many more worldwide. The slight disadvantage is, in order to get I.C.L.E.I's help, you have to be a member of that organization, and that does involve a nominal annual membership dues. It is quite nominal. I believe for a city the size of Greenville, it was less than $1,000, but that was still a lot of money for our budget. So we decided we'd try and go ahead on our own. We know that I.C.L.E.I's methodology uses a software package called the Clean Air and Climate Protection software, and we found out that we could get a copy of that software at no charge from the US EPA, and that is true as long as the request comes from a member of government. Just as a private citizen, you cannot call and say, I'd like to have it, but there's no issue at all as long as an official from the government asks for it. Well, that's basically just saying what I said. It appears to be easy to use, and we found that to be the case. It was available at no cost. If anyone is interested, and the contact information on where to obtain it is not in the notes, you can contact Kara afterwards, or you can contact me afterwards, and we'll let you know how to go about obtaining it. Most people probably already know this, but those are the three primary greenhouse gases. Carbon dioxide is the overwhelming majority. The other two, the emissions are less lower. They're important only because they have a much higher effect on greenhouse than carbon dioxide. Methane is 21 times as potent. Nitrous oxide is 310 times as significant. The software was probably originally developed to calculate air pollution emissions, so it is called the Clean Air and Climate Protection. It does also make estimates of the emissions of some other pollutants. When we first learned about this, we were kind of excited about that and thought that would be important in our work as well. And this is kind of lost priority, and we ended up concentrating just on the greenhouse gas emissions. One of the problems with this is you can make generalizations on greenhouse gas emissions, and if you generate electricity from fossil fuel, the mathematics to produce the greenhouse gases are pretty clean. If you are looking at pollutants that come from the production, it's very dependent on how you generate it, what fuels you use, what kind of pollution control equipment you have, etc. So when you get the answers on these pollutants, they're really not something that you have a lot of confidence in and could say, this is true for my state. It might be true on average, but it could be totally out of whack for your particular state. When we started looking at the software, it strongly encouraged us to look at this from the point of view of greenhouse gases that are emitted because of government activity, and then greenhouse gases that are emitted from the rest of the community or the public at large. They somewhat took this approach because the government emissions were something that the government control directly, so that was kind of like things that you could go out and physically do, whereas the many things in the community are things that you have to go out and convince other people that they want to do. The software breaks the government analysis down into looking at the energy that goes into buildings, vehicles, streetlights, water and sewer. It had a category for how much fuel employees are using commuting to work and how much waste went out and eventually resulted in greenhouse gas emissions. And the breakdown of the community is probably fairly obvious. We tried to look at residential, commercial, industrial, transportation, and once again, solid waste. The software gave us the option of pursuing this in as much detail as we wanted to or thought was practical. So we could look at the government as a whole, or we could break it down into various departments of the government. And I guess the harder you work and the more you break it down, the more useful information you might have to go get results. By the same token, the more you try to categorize the data and break it into subdivisions, the harder you have to work, and to some extent, the more assumptions that you make that may or may not be true. So in the end, we ended up just doing an analysis for the operations of the entire city government, and we ended up doing the entire community just as one block also. Greenville is extremely logical, broken down into a very large university component, a very large medical center component, and then maybe 2 or 3 different residential areas. But once again, it was much easier to get data for what the utility company was providing to the whole city than it was to go visit each of these individual blocks and get their precise numbers. And there was considerable resistance to go and getting it from private things like the medical community. The way you can use the software is you can either look at the data in aggregate. We consume so much electricity and natural gas, we consume so much gasoline, so much diesel fuel, etc. Or if you're really going to do a detailed job, you can look at how many buildings you have of high efficiency, how many you have of low efficiency, and assign the utility uses to each kind of building. The benefit of that is you can then make projections forward and backward as to your utility and energy usage based on if you have so many buildings and your population is 40,000, when you go to 60,000, you can anticipate those number of buildings will grow, etc. Once again, we found out that it was probably more work than we were willing to put in to try to do the detailed modeling. We ended up doing the calculations just based on total energy consumption.